For 2.2, number 8, white ln x dy dx. Oops, no, dx dy. Just noticed that. Is equal to this fraction squared, y plus 1 over x. Okay. Let's go ahead and square the top and the denominator, right? Numerator and denominator. So y ln x dx dy equal to, FOIL this out, you'll get y squared plus 2y plus 1 over x squared. So now I'm going to move this dy over there and this x squared over here. So dx will stay here with the ln x. I'm going to multiply it by x squared, right? I'm going to divide by y over here and multiply by dy. Okay. This will be a by parts. You can use a tabular method on this guy a couple of times, or you can do by parts maybe twice. This should be pretty straightforward. So let's go ahead and do this side first. So I'm going to integrate both sides. This will become, so divide every single term by y. Let me move this down a little bit. I don't like that it's so close. Okay, so we got the integral. Yeah, that's better. X squared ln x dx equal to the integral of y squared over y dy. So I'm going to divide every single term by y to make it easier to integrate. Sorry. Okay. So we'll deal with this in a little bit. So you agree that this is just simply y dy, right? This will simply be 2 dy, and that of course is going to be an ln integral. So this will become y squared over 2 plus 2y plus ln y plus c. So this side is done. Yeah, you cool with the algebra along the way? Any steps you might have missed? Cool with the integral part? Okay. So now I'm going to work on this guy. So integral, we'll just set it equal to this in a little bit. So let u equal x squared, du will be 2x, dv will be, actually, this would require an integral by parts itself, so we have no choice but to choose this. See what I mean? Like I wanted to make this the by parts part, but it's not going to happen. So let's see if we can have it repeat itself or have another trick. We'll see. Let's apply the formula one time. So u times b ln x minus the integral of v du. Yeah, it looks like we're good. Okay. So this will become x cubed over 3 ln x minus x to the 4th over 12 divided by that, which will reduce it to a cube, plus your c. So finally, we're left with x cubed over a third factored out of ln x minus x, actually just 1/4. I'm not going to put the c since I put it on the right-hand side. It's not wrong, but you're just going to have to relabel the c over and over again. So why do that, you know? So this is the right-hand side. Sorry, left-hand side, and this is the right-hand side. So our answer, final answer should be this equal to this. Right, that was the same question you had, right? Nothing was different. Okay, let's double check everything. Oh shit! Shoot, sorry, I made a mistake right here. This, you need to cancel this before the integration. That doesn't make sense otherwise. So this should be a 3 and a 9. You can't just integrate and then cancel. It doesn't make sense. Do you see the issue? But anyway, other than that, it's done. I'll show you the answer just in a second. So this will be cubed, and then the 3 will be divided by 3 again, which is multiplied by a third. And that'll be it. So final answer will be, so final answer is going to be x cubed over 3 ln x minus x cubed over 9 equal to y squared over 2 plus 2y plus ln y plus c. This is what they got here. Any questions on any of those steps?
I don't have a question about your calculations, but I was wondering, is it possible, not like for 100% of our homework, but for some of them to at least get the like worked out after, or what the answer should be? Because there was like 1 or 2 that I got wrong, and I wasn't sure where I messed up. But
Okay.
I've used this system before, and I know that it would tell you like step by step, like where your calculations may have went wrong. I don't
Mhm.
know if that's possible for like maybe 5 on our homework or even less. I just sometimes I mess up just like that, like very small parts.
You're wondering if there's like a setting for to show like some where you went wrong.
Yeah, yeah, some of the, or at least some of the steps
I know
where I
some of them have it, right? But some don't, or none of them have it.
none of them have them as far as my knowledge.
Yeah, I'll check, but it might be that this class doesn't have as much content as other classes.
Got it. Which
Like I'm
makes
thinking because
it a
it's not like.
little,
I'm sorry, go ahead.
it just makes it a little harder because I mean, the problems are longer, right? As opposed to
Mhm.
any other class. So I was kind of hoping that there was something else that could help support, I guess, where my calculations go wrong. Because it's very minor. Like it's just, a power or something like that. Something
No, I hear
very,
you. It's like in Cal 1, they have all these like, or Cal 2 even, they have a lot of little in-between steps. And then this class, I was checking, and I haven't seen much, but I'll see if there's some setting I missed, but it might not have anything.
that's
But
weird.
yeah, I'll
Because
try to.
you would think it would get, I guess, more. Um, I don't know. I thought it might have it, but it's okay if it doesn't. I was just asking,
Mhm.
um, just in case
No,
it
yeah,
doesn't.
yeah, I get it. I'll make sense. I mean, I'll check because they should. It would be nice, but I'm thinking there's more money in developing content for the lower level classes instead of this class. I think
Got it.
that's probably what it is. But I'm a little cynical, so
No, I understand. I completely get it. There is more money in, college algebra and
like I feel like that one has all kinds of extra shit.
yeah, for sure they do. And a lot of YouTubers, but differential equations isn't it's few and far between. It's a different language, different accent that
Yeah, for sure.
surrounds them.
You're like kind of. I mean, I remember my professor told me once, like the further we go, the more alone we become. There's just less and less people that can help you.
It's very true, and I think for me, because I like to really understand exactly what it should be, it's hard. So I can problem solve what another problem might look like. It's hard to do that in this class because it's either this way or like linear algebra too. It's a bunch of puzzles and stuff like that, and it's been a little difficult for me because I'm like, oh, I understand what needs to happen,
Right.
but that there's multiple ways to solve it is throwing me off. So I don't know.
Yeah, linear algebra is like the first. And if it's taught correctly, it's just like the first taste of what math is supposed to be, like proving theorems and.
Yeah, it's really neat. It's just different. And so I'm taking both this semester. And so she has her content uploaded weekly, but even then, like it's really cool to understand. But like this class, I was just like, okay, this one's a little bit more tricky. And since it's a culmination of, Cal 2 and algebra, it's like, oh, which rule do I remember? Which goes integrated in this part. And so,
Yeah, it wants you to remember a lot of stuff from all your math classes. It's pretty tough because of it.
yeah.
Uh, but yeah, I want to try to start doing more problems with you instead of lecturing. So I think that might work better. Now that I'm going to be loading all those videos in there, I think that might be best.
And I don't know if I missed it. When is our projected quiz or exam date?
Oh, the exam, I haven't made it yet. But let me check the schedule. Yeah, who are you taking a linear algebra with, by the way?
Anita? I don't know if you know.
Oh, where
I
at?
think I think that's her first name. Let me see.
Which school is it? Do you remember?
I don't know, but I can pull it up right now. Let's see. She is at SAC, and I think I was kind of weary about taking it there, but I had some good professors before at SAC. So.
Yeah, I think so. What I'm gonna do is I'm gonna unlock test one sometime this weekend. I'm hoping to make it, if not by Monday for sure. And then you have that entire week to take it.
Okay.
So I mean that's what it should be, but I might postpone it a little bit depending on how far we get, because we'll probably finish 2.4 and 2.5 this week. And then I'd like to review, so I might unlock it and just leave it open for 2 weeks, and you decide when you're ready. Okay.
Okay. Yeah.
So like that way you can. I mean, I don't want you to put it off, but you could give you extra time to prepare.
No, yeah, I understand. And so it'll be section 1.1, 1.2, 2.1, 2.2, 2.3, and 4.
Yeah, it'll be all the way till 2.5.
Okay.
I'm not going to include 1.3.
Yeah, you said that was extra credit.
Yeah, or 2.1. Those will not show up on test
Okay.
one. But for sure, everything else like the EP and linear, and then 2.4 and 2.5, which I'll upload soon. We can do some homework problems next time.
Okay.
Do you have any other problems you're struggling with, and did this one make sense to everybody?
Yeah, makes sense.
I had a question on problem 14 on 1.2.
Let's see. One point two, problem 14. So they give you a curve, correct?
Yes, I wasn't quite seeing what they were wanting on that one. I wasn't quite following.
Let's see. Yeah, it's worded really weird. Let's look at it together. I'm not sure I care for this question now that I'm looking at it, but so you understand that the derivatives are slopes, right?
Yes.
And this is a solution curve, meaning that if I take a derivative, I should have a slope at that point. So which answers will pertain to this, right? So first of all, y1 equal to 1, that's a physical point on the function, so it has to be right on there, right? So which of these are true? That y negative 1 equals to 0. Negative 1. So yeah, that's technically true. But the derivative at 1 needs to be positive. So anything that's negative would be wrong, because at 1 we're increasing, right?
Gotcha. You're looking at the slope of the solution curve.
Yeah, so
Derivative.
tangent to that point, it has to be positive. So I would eliminate everything that is negative. So these are BS. It's not 0 would imply a peak, right?
Flat or peak, yeah.
Yeah, so that can be it. Right away, I would eliminate all of them except these two, just by looking at the slope.
Okay, that makes sense.
But yeah, I agree. The question is just, I think, a little strange. I wouldn't word it that way. But I'm glad you brought it up. Okay, you guys have any other questions? If not, I'm gonna open up 2-3 and take some problems. So 2-3 was the integral factor. I basically recommended you should use the formula once you get your equation into standard form. Practice. Okay, so this one is no big deal, right? It says find general solution given the differential. So you technically could do separable variables, right? You could separate them and do the straight up integral on both sides. But they want us to start using the new technique, right? And we said that the P of X was the function or number attached to the Y once it's in standard form. So for number one, let's just, I'll try to do one of each type until we run out of time here, if you guys are good. So let's do number one, really straightforward problem. Write it down and I'll switch back over. Find general solution of the given variable. Okay. So they give us dy dx, and I switch back. One sec, try to adjust this camera here. Is equal to 3y. So standard form is this way. So P of X is equal to -3 and F of X is equal to 0. So using that formula, the general solution Y is equal to e to the negative integral P of X dx times the integral of e to the integral P of X dx but our F is 0, so this entire piece will be gone. So Y is equal to 0 plus C e to the negative integral -3 dx. So Y will be equal to C e to the 3x. Right, no big deal. But you have to put it in this form first. Is there any questions on this first one? That's how they got this here. And of course, E is defined everywhere. Who cares? All right, this one is similar. Let's see, there's another weird one. Let's try number 3, I guess. You guys cool on number 1? All right. This is number 3 from the homework. I'm going to label them for you. Find the general solution. So y prime plus 3x squared y equals to x squared. So we're already in that form. So p of x is equal to 3x squared. F of x is equal to x squared. So y will equal e to the negative integral 3x squared dx times the integral of e to the integral of 3x squared f of x dx plus c e to the negative integral 3x squared dx. All right. So that'll simply become e to the negative x cubed times this integral probably will require substitution most likely. So this will become x cubed times x squared dx. This will simply be c e to the negative x cubed. Okay. So this will be pretty straightforward, right? That u equal x cubed, dx is, I'll do it over here. Dx is 3x squared. So du, sorry. So du over 3 is equal to x squared dx. So that will be substituted, right? So the integral of e to the u du over 3 plus c e to the negative x cubed. So that will become e to the negative x cubed. Integral of that guy is just itself. So 1/3 times e to the u, which is 3x cubed, plus c e to the negative x cubed. These cancel, leaving me with 1/3 plus c e to the negative x cubed. Any questions on number 3? Okay. Is 2.3 straightforward, or have you guys started on that section yet? Okay. We'll move on to 2.4 and start some of those then. You guys are good. So the only thing you need to know for 2.4 before we start the problems is, what does it mean to be exact? And if they are exact, then you can use this technique. Okay. That's all we gotta do basically. You test for it and then you apply it. So let me give the definition and the criteria, and then we'll start some examples. So a differential expression mxy dx plus nxy dy is an exact differential equation. In region R of the XY plane. If it corresponds to the differential equation of some function f of xy defined in R. A first order differential equation of the form so basically what we just said, mxy dx plus nxy dy is equal to 0 is said to be exact if the expression on the left side is an exact differential. Okay. So then in order to check, which we'll explain in a second, you have to be able to take partial derivatives. So that's going to be important in a little bit. Okay. So basically, so here's a good example in the book. For the definition, I mean. x squared y cubed dx plus x cubed y squared dy is equal to 0 is exact. And why is it exact? It's because of this. So you take, so this right here is going to be called the mxy. And this is going to be the nxy. So what you do is you take the partial derivative of m with respect to y. So see how this is attached to the dx, right? So you take the partial of this piece with respect to y, and that must be equal to the partial of the n piece, this piece, with respect to x. If they are equal, then they are exact. So you just check. So what is the partial? You guys remember how to take partials? Or no? Have you guys ever used partials? All right, I'm gonna assume yes, I guess. So if I'm taking a partial derivative with respect to y, that means that I treat the x squared as a constant, right? So this is like, pretend this is like a 5y cubed. This is just some number nobody cares about. It will not trigger a integration by parts, or sorry, product rule or quotient, that type of stuff. You know what I'm saying? Like this will not be a quotient rule because this is a number. So derivative of the y cubed is going to be 3y squared times that garbage there. So x squared times 3y squared. Or if you prefer, 3x squared y squared. Okay. Any questions on the partial? Okay. So now we'll do the partial. Actually, 1 second. Partial with respect to x of the n piece. And you can tell it's going to be the same, right? So I'm only going to do the derivative of the x piece, which gives me 3x squared y squared. And these are the same. So since partial m, partial x is equal to partial n, partial y, then this dE is exact. So this is another technique for solving differentials that we're about to do. But first you need to check, is it exact before you do it? Okay. Are there any questions on how you check? So on the exam, I'm going to be expecting you to verify that it is exact, and then use that technique to solve the dE. me. All right, let's do an example now, actually using the technique step by step. Remember, we have to check first. Let me know if you're not good, if you're still needing to see that page or not. Otherwise, I'm going to start writing the example. Solve the exact DE. Okay, so here it is. 2xy dx plus x squared minus 1 dy equals to 0. So first thing is you take this, remember this is the m, right? And the n. So check the partial with respect to y of the one that has the x on it. So that'd be the partial y of 2xy. So that will be 2x. Now, partial of n with respect to x would be the partial x of x squared minus 1. Derivative of any constant, no matter what partial I'm taking, is 0. This is respect to x, which gives me 2x. So they are equal. This DE is exact. Okay. Any questions on that first part? All right. So what you're supposed to do is take the m and integrate it with respect to dx, and understand that there's going to be an extra y term that will appear. Okay. So the f of xy that we need is equal to the integral of m xy dx. So that will give us the integral of 2xy dy, which is equal to dx x squared y plus a g of y piece. Because they're exact, we're going to add this g of y here. Okay. So this is the method of solution. It's kind of like a constant. So we're just going to have an arbitrary function. Then we're going to differentiate f, right? Because this is f. And we'll solve for gy. there's like an indirect way to find the solution because we can't use separable variables on this or integral factor. So if they're exact, we can use this technique. All right. So here we go. So you take the derivative of the f, but with respect to the other variable, right? So you integrate with respect to x, then you take a derivative with respect to y, a partial. So that would be the partial y of x squared y plus g of y. Okay. So that will give us x squared plus g prime of y. Because I'm taking derivative, a partial derivative with respect to y and to keeping everything else constant. So derivative of this g is g prime because it's a function of y. Derivative of some constant times y, right? Like pretend this is 5y. Derivative of 5y is 5, right? That's what this is doing, keeping the x constant. That's how partials work, just in case you forgot or never seen it. Okay, so that's step one. So step one is check, right? Step one right here. Step one was up here. Step three, right here. Step one, of course, is just checking. So step four. Step four is set. Let me write the instructions out this time. Set the partial f with respect to y equal to the nxy. So we found it to be this equal to x squared minus 1. These will cancel. So now we have g prime of y equal to -1, right? Let's integrate this. Integrate g prime of y, that will equal to g of y, which is equal to the integral of -1 dy, which is -y. So g is -y. So finally, we're done. So f of xy, which we had already found, is equal to x squared y plus the g that we found, which is actually minus y here. All right, so one more time. Step one, check if it's exact. If it is, you are allowed to use this technique. So step two, integrate the m and add this arbitrary term of g of y. Once you have this, take a partial with respect to y. So once you've done this, right, derivative of that, you'll set it equal to the n, because n is related to the partial. So right here, partial is equal to n at step 4, and you solve for g. The whole goal is to solve for g here, because once you have it, then you have the solution, because that is equal to fx y. Okay, so that's the approach for exact. Okay. there any questions on the first one here?
Could you repeat step 3 again and step 3 and 4?
What's that, one more time?
Could you repeat step 3 and 4 one more time?
Yeah, so so it's 2 is okay, right? So
Mhm.
once you find f of xy, which is technically the solution to the differential, you need to solve for g. Okay. So you take a partial with respect to y, which gives you a g prime. Then you set this equal to the n piece, which is that part, right? So right here, you're setting the part that we found, that we found in step 3, equal to the n. And then you just solve for g prime and take an integral. Once you've done that, you know what g of y is, which is what we needed up here. Once you have it, just tack it on and we're good. And we'll do some of these homework problems on Wednesday as well. I'm low on time since I had some technical issues, but does that make sense?
Yes.
We'll do more of these next time. Just look at them and see what you think, and then we'll go over it again. I'll add more details on the steps here for you. Okay. On Wednesday. We have 5 minutes left. Do you guys have any questions or concerns? All right. Well, I'll see you Wednesday then. I'll post some videos on 2.4 and 2.5 today, and I'll post this or this as well.
Have a good day.
You too.
Bye. Thank you.
Thank you.